Hi, everybody. This is Nikolai, and this is our second episode of Show Me Your REPL. And my pleasure to meet Andrey Listopadov, or Andrey Orst. This is experienced Clojure developer. So Andrew is a co-maintainer of a very interesting project, which is called Fennel. And this is a Lisp implementation, Clojure-like Lisp implementation on top of Lua. And I think Andrew will show us something. So welcome, Andrew. Доброе утро. Welcome to the show.
Hello, everyone. As already mentioned, yes, I work in Clojure, but not like that many years as one may expect. I have about 2 years of professional experience and maybe a month or two prior to that. So it's not like super huge, but I hope things I will show today will be of use to someone.
What do you do in Clojure? Is it web development or data science?
It's informational security. I work on backend services that prevent data leakage. It's a DLP system. We develop a lot of services. It's like a microservices architecture, which has a lot of services in Clojure. Some of services are written in other languages like Scala, C++. So it's a big system. And Clojure is a big part of it, I can say.
Interesting. How many Clojure programmers do you have?
Clojure programmers, I think we have 7 Clojure programmers, not a lot. Maybe even less.
Yeah, that's pizza team. It's a good number.
Yes. I mean, 7 is not a lot, but for our tasks, it's mostly fine. I think we have enough.
I think if we're talking about Clojurians, so it should be multiplied by 5, yes?
Yeah.
Okay, so Andrew, let's start. So we are talking about, so welcome, Andrew. So in this screencast, I hope you will share your tips and tricks and tooling and your workflow, how you're writing code interactively. Yes, and let's start from the basic questions. So what is your environment? What is editor? What terminal do you use? Maybe something interesting here. And let's start the sharing screen here.
Okay, hope you can see my screen.
Yep.
Great. So this is Linux. It's Fedora. I'm a huge fan of this distribution. It's pretty simple and also works quite robust. And as you can see, I don't have any like super crazy customizations. It's pretty vanilla because mostly everything that I do inside of Emacs. So the second question was my editor of choice. It's Emacs. And it's not like an editor per se, because Emacs is, well, it's not just an editor, it's more like an application platform. So I use a lot of stuff inside of Emacs, like I read my emails in Emacs, I manage Git repositories from Emacs entirely with my Git and like other stuff. So being an application platform, Emacs is really great at running Vim. So I use Vim inside of Emacs. This is actually a joke. I don't do it. I'm using Emacs, and here it is. It's pretty much like a vanilla Emacs. I'm using a light theme because it's easier on the eyes. But if it's not okay, I can switch to a dark one.
Yeah, that's good, but maybe you can increase the font.
Okay.
And can you tell how you started with Emacs? What was your trigger? And what is your recommendation for the newcomers? Should they start with Emacs or look into the Visual Studio Code or something more?
Well, as much as I want to say that absolutely yes, the actual answer would be it depends on you as a person. For me, Emacs was very interesting because I wanted something that I can make my own thing, because Emacs is very, very customizable. And prior to Emacs, I was using Vim for maybe 5 years. And this is my 3rd year in Emacs as my main editor. So I have a lot of experience in Vim and Emacs, I guess. And between Emacs and Vim, I also used Cocoon. I'm not sure how to pronounce this name, but it is an editor which basically doesn't have any language for configuration. You can do all of the scripting in Bash, basically. And then it hit me because in Cocoon, I was using other languages like Perl, I was using Lua, I was using Awk. And then I thought to myself, well, if I'm using all these proper languages, maybe there is an editor which has a proper language built in. And Emacs was kind of there, and I've tried it, and I absolutely didn't like Emacs at first. It took me maybe 4 times before I actually liked Emacs. So if you can, you should try Emacs, I would say, but if you don't like it, don't force yourself. It will grow on you periodically, and sometime eventually you will use Emacs, I think. That's at least that's what my experience was like.
So your way was quite conscious. So you
Yeah.
make your choice. You made your choice. Yeah.
Yeah.
Okay. So, and are you using any build of Emacs like Doom or SpaceMax, or it's completely yours configuration?
Yeah, it's completely my configuration. I'm quietly opposed to distributions like SpaceMax, Space, Vim, Doom Emacs. This stuff is not for me because unless I can understand thing I'm using on a quite deep level, I can't use it. So since Doom will hide a lot of stuff from the user, and SpaceMax also has its own kind of layers, things that they use for configuration, it's not very transparent, and I just don't like it. So I use vanilla Emacs, and my config file is not like super big. I have 2000 lines of code, which is mostly use package directives for like various packages. So it's not very hard to configure Emacs this way. You just do it via trial and error, I guess.
Okay. But as an ex-Vimmer, so I'm pretty sure you're using evil mode.
No.
No, so you're not using evil mode. So
no. I'm using default Emacs key bindings, and I've made sure to not tweak any key bindings from the standard, because when I use an editor not on my machine, I want to be comfortable with it. And if someone else would use some kind of different key bindings from mine, it will be a pain for me. So I guess I will keep things standard.
Yeah, that's interesting, because I never heard that Vimmer give up with the mode editing.
Well, it's not like I don't like Vim's model editing. I mean, Cocoon is also a model editor, but unlike Vim, it's inverted paradigm. So in Vim you do action object, and in Cocoon you do object action. So you select an object and then you perform an action, and Emacs is in a way the same. It's like it doesn't have a distinct mode, but you also operate on selections. You can like select stuff. You can select stuff inside selections, and so it's mostly the same. It's just the lack of mode, and it takes some time to like learn a new set of key bindings, but I don't say I miss modes too much.
Okay, interesting. So let's move forward, and can you show us how you start the Clojure project, how you connect to the REPL? So are you using Cider for that?
Yes, I'm using Cider, and actually I would like to talk about one more thing before we continue, because questions mentioned terminal emulator. And I think it's quite important part here, because I don't use any terminal at all. Because Emacs can do what can terminal emulator do. Obviously, I can run terminal inside of Emacs, but that's not what I mean. I mean that Emacs can run things that are like terminal commands, but you use Emacs to run and interact with them. So in this fashion, if we go to my project directory, which is right here, and if I wanted to create a new project, like a test project for this talk, I would typically use an asynchronous shell command from Emacs. You can see it down below. And I am using line again. So in my case, it will be plain new. I guess. And this basically created a new project for me. So show me your REPL. It's a new project that we created via Leiningen, and I use Leiningen not because it's better than anything in particular. It's just what we use at work. And I am the most familiar with Leiningen projects. Dips is also great, I guess, but in my personal experience, every time I try to use dips for managing a project, it has a lot of tedious inside of it. You can create like in Leiningen, you can specify variables for the REPL, so it automatically configures like Varnon reflection, for instance. In depth, it's a bit harder. You have to mess with user CLG, which will do stuff for you. And while it can be done, I think Leiningen is just easier. So in this project, I only wanted to show how I create projects. So usually I do it with an async shell command, and this is my main interface for all shell interaction. I run shell commands like I build project with this thing. I deploy stuff with this kind of thing. Actually, not quite. I'm using project how to call it, project helper, I guess. It's a package for Emacs which manages projects files, and it's not very representative to show it on empty project. So I guess we better take a look at project that has some files, and I can demonstrate things as I do. So, for instance, this is a project which I made as a self-educational task. It's implementation of a programming language from the Crafting Interpreters book. It's a great book about writing your own interpreters, and I'm yet to finish it because in the second part you are actually writing a whole virtual machine which implements bytecode like runner. In this case, it's just a regular abstract syntax tree interpreter which folks all the code. So in this project, I have a lot of files, and when I usually work on any kind of project at work, I use, as I mentioned, project package project.
I think it's Project Till by Bozhidar Batsov, or
no,
it's different.
It's built in Project L, which is a more recent package for Emacs, because projectile exists for like 10 years or so, I guess. And project only exists for about 5 years, or maybe even less. But I find it, first of all, it's really good. And second, I don't like using external packages if the built-in alternative is good enough for me personally. Unless I have something I need from the package which it can't do for me, I will go for an external package. But if built-in thing does basically what I want, it's good. So I'm using a built-in one.
And can you show what the Project L can do?
Yeah, sure. So in this example, I've already input Ctrl-X P, which is something like Ctrl-C P in projectile, and it has a lot of various functions. In this case, I want to open a file, so I press F, and project will basically list me all of the files inside the project, and I can fuzzy match through them like you would do in projectile, basically.
Yeah, so let's open AST file.
AST, okay.
Okay.
So this file basically consists of a lot of def records for the AST of the language, but I think I have a test for this file as well. So unlike project can't switch between test and implementation, but I have a separate package for that, and I have configured it in such ways so I can do it via project, basically. So project can be extended to support features it doesn't have with new key bindings that you can add to a menu. So in this case, Control XP and capital T will take me to the test. So I use this pretty frequently at work as well, because tests are really important, I guess. And basically, this is what.
And you can get back with the control.
Yeah, the same shortcut that you back. Yes. So right back where we were before. And the REPL is basically always running on my local machine, even at work. We use local REPLs unless we are working with like a real system. In this case, we are using remote REPLs, which are basically the godsend ability of an REPL to run a REPL server on another machine and connect it via SSH. But I will not be doing it here because, well, obviously I don't have any connections to show it. But it's
do you have real cases when you really connected remotely to the REPL and do something?
Yes, of course. I do it all the time at work because our servers on which we run the whole application, they require a lot of machine power basically to run it, and we can't run it inside of, say, a container on a local machine. So we connect to a server and we share servers between various developers. And we have even some situations when a lot of developers are basically connected to the same REPL, and we are doing stuff and basically annoy one another because, hey, you turned on debug mode and I can't do anything now. Hey, I'm also working here. So
are you using Tmux for that, or
what?
Tmux for the shared sessions?
No. It's just an REPL shared session. I mean, so I'm connected to a server, to an REPL, and another programmer also connected to that server. And when I mess up with the environment, they can also see it when they try to do stuff on the server, basically. So if I turn on, go on.
Yeah, because for example, we are using this sometimes. So we're doing the full-time pair programming, and some guys as well sharing the machine, and they starting Tmux. And in Tmux, you can start the session where you can connect to this bash session, and then you can run Emacs there.
Yeah, I understood. No, it's not like we are using the same server. I mean, we are using the same REPL.
Okay.
Yeah. So here I'm just using the default connection to a REPL server. It's basically a shortcut in Emacs for Cider, which opens a new REPL. It takes some time, so it will load in a minute. Yes, here it is. And my typical workflow is that I don't use REPL much. I'm evaluating code from a file, but this particular file is not really good at it because it's def records. They are meant to be evaluated only once. So let's go to
but that's interesting problem. So for example, so you said that working in REPL with def record is not very convenient because it's hard to override it, or what your tricks to do this? Let's say you evaluate this and then you change your def record.
Usually I just reload the whole REPL with the reload command, refresh, I mean, because I don't keep a lot of state in the REPL. I don't think it's practically useful as a concept.
But the refresh command is coming from Cider, or is it like namespace tools? So I don't remember exactly.
I think it's coming from Clojure itself. Cider just conveniently wraps it into a comma command. So it has a lot of comma commands when you press comma key, and instead of appearing as comma, so for example, if I type some text and press comma, comma appears as is, but if I type comma on the first character of the prompt, it prints me a lot of commands that I can use, and basically this command comes from this. I don't know exactly how they manage to call it behind the scenes, but I think they are calling it basically closure REPL / refresh or something like that.
I don't think it's a standard library. I think it's some namespace tools or something like this. We will check here. So, and what is most popular CIDR commands you're calling through this comma? Like your top 3?
Like free refresh and require REPL utils and nothing more. So my top 3 is actually top 2.
What is require REPL utils? Yeah.
It brings commands such as doc, which brings the documentation of a function, basically, and it brings also a command source, like defn, for instance. It will print source code. It's handy when you are working on a remote connection and you can jump to the code, because the REPL doesn't have CIDR middleware which implements jumping to a definition, but it can still print source code, because these commands are actually also part of Clojure, and you can print source code and examine if you are working on a remote REPL. It's very handy because you never know what kind of state the REPL currently is. If someone changed a function, evaluated a new variant, this can help. So I use it periodically, basically not very often, but sometimes it's necessary to do so. And also, as you can see, I think it's a minor tweak, but I've made so the prompt is actually multi-line. So the namespace comes on one line and the prompt itself on the second line, because in Clojure, unlike common Lisp, say we have sometimes a very long namespaces. Like we can have project .subdirectory, .submodule, /namespace /function, and it's basically very, very long in the REPL. And when you are typing code that is indented so far right, it's not very convenient in the REPL. But as I said, I never actually write code in the REPL unless I want to do rapid experimentation. So there is like a belief, I can say, in Clojure community that you should not use your REPL for programming, basically. So most people are using like comments inside of the file, and then they write their functions, different foo, x plus 1, I guess. And then you evaluate it, and you can run it from that namespace. So you can go to the REPL and run it.
But you can stay in the
yes,
buffer.
But you can stay in the buffer and run it there, yes. Like this. And I am kind of iffy on both approaches, because for one, I don't really like to clutter my file with code that basically a dead code, because it's inside of comment. It just makes a lot of noise, especially when you are opening a new file, opening an existing file in a project, and you have like 300 lines comment at the bottom, which basically lists of the experiments of other people that are working with you on this project. And it's not great, because often this code gets old and doesn't work anymore, and you are afraid to remove it because someone may actually need it. So I am a bit resistant for this practice, but I also don't like to run code in the REPL, although I actually do it when I want search history, for example. Like for this project, I have to do 2 particular settings for REPL environment for debugging purposes, and I don't want to put them into Leiningen like profile, because I don't need them all the time. But when I do debugging, I want them to be there. So usually I just search for like set, and I can basically go through history, and here there I need print length and set print level in this particular project to be at least 3. unless it will go into infinite recursion when we are printing some data structures, because data structures in this project so happens they are like self-circular. So in this sense, I'm using REPL when I want something to stay up in history, and I have a pretty long history on my work machine. And this history is basically like my second brain, because I don't have to remember exactly what I want. I can search the history for some specific command for this specific project. So like if I'm interacting with HTTP server somewhere from Clojure REPL, I usually put it in the REPL and then search it back. I think it's pretty useful.
But can you show your standard flow? Let's say we want to implement the function plus, and so if you are not using REPL, what is your standard workflow? How you start and how you finish?
Just I guess just as everyone else, I'm going to a file where I will be needing this function. Like in this case, let it be this file. So I'm just writing the function plus. And let's say it takes some arguments, like it will take 0 arguments, x and y, and x, y, and the rest. So so I just do it like this, and after I execute it, usually
how you try execute it. So that's important. So okay, so this is quite simple function. Yes, you write it as a just from scratch. But let's say it has some logic which you don't yet understand how it's exactly going. What's your next step? So you write your first implementation function. What is your next action? Are you creating comment block? Are you go to REPL, or are you writing tests? So
usually it depends. I mean, if it's a small function and I just happen to have a REPL open like here, so I can just go to the REPL and just use it.
Okay, so you jump
if
into
I have
the REPL.
Okay. If I have a REPL and I know it's in the correct namespace, so I can do. If I know that the REPL may be in some kind of state where it writes logs, because when we are connected to a REPL from the remote, it can actually be used as a logging buffer as well, because it prints all the logs from the server in the REPL window. And I maybe don't want to clutter it with unnecessary information, then I will use comment. And if the function is particularly complicated and it has like requirements on pretty specific input, I will always use comment, because it's easier to edit and run it via the standard k bindings. So if I had to say test this function with some kind of map, obviously this function doesn't accept a map, but if this map had a lot of like fields, keys and values, I would use plus, and then I will obviously write this huge map either from hand, or I will take it from like some other place where this code is expected to be used. So comments are for more complicated usage, and REPL is for throwaway usage, or for when I want the final example of this comment function to be available for me later without storing it in the Git repository. So I will put the final version of a comment into a REPL without the comment, obviously, and then this function will be available for me for searching, like I showed before.
But yeah, what's the lifetime? What's the evolution of this code? So you said you never left the comment section, yes? So okay, so you wrote this function and you're going to commit it to the Git repo. Yes. What's your next step? Write test for that function, or are you a test-driven guy?
No, I won't say I am a test-driven guy. Usually, most of the code that I write, I test right away in the comment block or in the REPL, which may depend on the environment. And After that, I can accumulate these examples either from the REPL history or from comment section into tests. If it makes sense to test this function, because not all functions are meant to be tested. Usually I test functions that are part of the public API. So I have a somewhat big article about how you should do your test when we are talking about coverage. And I think that if you are going to first take your time and cover as many parts of your code with coverage testing, you will see what kinds of code actually needs to be tested in unit tests after that. So I usually try to maximize code coverage first, and then when I see that some kind of parts were really hard to get, obviously these parts might need to take a closer look from me. So I will write test, but I already shown you how I switch between test implementation and test file. So I think we will not need to write a test for this particular function, but I can show you that my tests for this particular project are exactly what I am talking here about. So I write a lot of tests that are pretty simple, and then I try to make sure that my coverage is okay. And after that, I am going for somewhat weird cases in which some more interesting parts of the function can be tested.
Okay, let's run this test. So are you using Cider run NS test?
Yes, I'm using Cider. It can run test for my project files because I've specified this project with the profile which knows that my tests are located in the test directory, and in this case all tests are passing. But if we make some kind of test fail, like here we can just delete true, and if we rerun tests with the same hotkey, it will, whoops, I forgot to eval. Right now it will fail. Yes, and as you can see, Cider basically marks the tests that failed, and usually I don't have tests open, so I just navigate from here to the test I want to see, and it will jump me to the buffer. So if I have only this buffer on screen, it will jump into the failing test. And usually I work from there, like I evaluate this test once again to make sure it's up to date, and I execute this test only in particular. So T will execute only this test, which is pretty huge test, but mostly our tests mostly our tests at work are small, like they have one or two testing blocks and not many is statements. No, not statements, is expressions. So usually I just rerun one test until I get it working again.
But do you use potentially you can evaluate only this form? Yes. So do you use this evaluation just specific form which is failed?
No, because most of the time there are fixtures which are important, and I'm not sure if it will work. And there are a lot of times when we have a let block over this testing.
Okay.
Which has some constants which test use, and running individual forms is hard because of that, because if this test say depends on the result, and the result in this case should be true, I can't really run this particular test as it is on its own.
Yeah, we use specific tricks, so we don't use let and tests, but we use def. It's an anti-pattern for the production code, but so we found it's very useful. Instead of let, you can do the def.
Oh, okay.
And then we're trying to write the test that it's potentially runnable expression by expression. So then for some complicated scenarios, you can focus on a specific form, specific line, and can kind of play it one by one, like debugging tests.
Usually, if I really want, to run one form, and sometimes there are basically situations when I really want it. I can break my code and just delete this line, put it here, and then I just remove everything else from the let, and now I can run. But it doesn't happen that often because, as I said, we don't have a lot of is expressions inside our tests. So usually it's enough just to use the ignore macro a few times, and this was too much, and run the whole testing block, basically. Well, in this case, it has more tests in the end, but in real workflow, I will make sure that I have only one form, basically. So
usually you just focus on specific failing tests, yes?
Yes, yes.
Using key bindings to run these failing tests.
Yes.
Interesting. And when you're working with a REPL which has a state, do you have some rules how to keep this state, how to work with this state? Because
you can see right here that I'm using a dev ones. And basically, if I have state, I don't have it in the REPL. I have it in the project itself, inside of dev ones that are used in the project. So usually it's safe to reload my project because all of the state that should be kept is preserved by using a dev ones. And the state that I don't care about is implemented using just dev. So if I was not to care about locals in this particular situation, when I reload my code, it will be dev. And this is pretty much how I manage state in the REPL. It's my main tool for that. I know people are using component systems like mount. What's the other one pretty popular called?
System, I think.
Maybe
component or system or component,
component, and there are a lot of them, basically. I've tried using mount. It's really great, but I don't think it's an answer for managing state in your REPL, not in your application, but in your REPL. So mount, for instance, will when you recompile your namespace, it will restart the affected module in the mount. And it will basically ensure that the state is correct. But again, if I'm already reloading something, I might just as well use the funds and preserve the state that I want to be preserved. Now, it comes with a small downside, because if you want to actually clear the state, you have to do this awkward maneuver when you remove the funds, replace it with dev, evaluate it, and you return the funds back. So you basically clear the state which you thought you will preserve. But I can go there. I can accept this small downside, because it's better for me to be able to reload at any time and not lose anything than to rely on some other systems that will do it for me, because Clojure already can do it. So.
Interesting. So we came up to the idea that the state should be pushed at the top as much as possible. So as we usually say that no dev at code at all, only at the near to the main function.
Oh, okay.
And the rest should accept this state, and usually first parameter is some atom, which keeps the whole system state, and then you can get the whole control over your state, because everything in one atom, and it's initialized at the toppest level. So no scattered state.
I think I actually have a project that does this. I have a few projects in ClojureScript, which is not my main technology at all. I'm just experimenting with ClojureScript, but in ClojureScript I have this state which has these events for JavaScript basically to be hooked on. And I just use these element events examples like state which is in the main file, and basically there is a very little amount of state otherwise in the program. So it's not like an atom, it's still an immutable thing. And if I want to change it, I have to explicitly change it and recompile, because ClojureScript is a bit more like finicky on the interactive workflow. The REPL is not like as good as Clojure REPL. I think no one will argue that, at least it's my experience. So yeah, I do kind of the same thing in some projects, but again, I don't think there is a universal silver bullet for everything.
Yeah, so, but there are some consequences. Yes, for example, if you're doing dev, so it's usually like when you're doing the REPL development, so you may have multiple environments running in the same REPL. Let's say test and dev. So, and when you're doing, let's say you're running the test environment with a connection to database, yes, and the developer version where you play with user interface, which interact with the REST API, or probably you're doing some multi-tenant implementation, yes, where potentially maybe multiple instances of your system. And if you're thinking that way, so then the dev becoming not very useful because it's on singleton, yes, it's in one place. And but if you explicitly pass state to all the function, and the simplest rule, make it atom, so you can reload it and inspect it when you need, so you can run multiple instances of your system and quite easily work with that.
Yeah, true, of course. I am not opposed to this workflow in any way. It can be very useful, and I actually have seen somewhat like how to say, it's not like a state, but it's capability system in which you can tell a certain function what it can do by passing it a map of capabilities. So for instance, if you have a logger and you don't want a logger to be able to connect to internet and run code, you basically don't give it a capability for that as a parameter. So it's a similar concept, I think, and I can see it pretty useful, yes. But in my experience in our project, we usually don't do it because, as you mentioned, we don't run tests that connect to databases. We mostly have unit tests, not like integrational tests. If we do have to test operations that we'll try to write or read, we usually mock. So and we use generative testing for actually receiving random data from it.
So you're a unit test guy.
Yeah, basically, yes.
Because there are two camps, yes. So for example, we are on other side, so we prefer the functional tests, and at least for the business code, yes. So it's okay for library to do unit testing, but so for business code, so we prefer doing functional test first, because it doesn't lock you on specific implementation, and you're testing your external API, yes, and you have a freedom to rewrite it with tests.
Yeah, sure. Well, again, I'm not like a fanboy of unit test. I can accept all of the approaches for that. It's just like what we are using today at work, and I happen to agree with it. So,
so that's the culture in your team now, yes? That you
yes.
prefer unit tests. And probably this is dictated by specific of your application. So you said you don't have database at all. So it's just calculations.
No, we have databases.
You have,
okay. Yes. Of course, we have databases.
But you don't write the functional tests.
No, we basically database serve as a storage. So we only write to it, we never read from it. In the services that I particularly work on, there are of course services which do like read stuff, and they have integrational tests, but they are not actually I'm not really sure on that because I never worked on that particular project, but maybe it has tests that are running with Clojure, and they use database. But it is complicated because our project is very large. So if you want to do like tests that talks to another service, for example, it may be very problematic because the other service may require like a lot of RAM, which you don't have, and you don't want really to make GitLab suffer with pipelines that like spawn an entire half of your system. So it depends. I kind of feel that it's almost always an answer for any question in programming. It depends.
Okay, yeah, it depends. And so another question. So when you're working with a huge data structures, yes, in your code,
yes.
So do you have some tricks how you introspect it? So let's say we have a huge map, yes, and how you introspect it in your maps?
Actually, about maps, usually we try to make it so our maps are small and fit the screen, unless it has a lot of components. But again, I rarely see maps out of context. It's usually when I'm running the code. And in this kind of case, I can show it with this project. We have a running REPL. So if we actually call a function, in this case, this run function in the REPL, run accepts a string, and it's an interpreter for a language. So it's not a Lisp, but as you can see, it returns a result. So usually when I'm into a project which I don't know yet, or if I'm fixing a bug which I don't know yet why it happens, I use debugger, because debuggers are amazing. And Clojure has really good debugger built in into Cider, I mean. So Control U and Control Alt X will mark this function for debug. So when we run it, we can step through, and basically once we have this result, this execution happened, we have a pretty big data structure. In this case, it's not very big, but I often use Cider's inspector, which can format your data structures in a way that you can navigate them with some key bindings, which I actually almost never do, because again, at work maps are not really big, but if I have to, I can enter like insights of this text representation and focus on something that I really interested in. Like in this case, I've entered a vector, and I can enter a map, and it kind of scopes interesting parts for me as I go. So I can return back and back again. And I find this really useful. And at first, I saw this talk about proto-REPL for Atom editor, and they had like interactive tree view of that data structures, and you can fold and unfold stuff. And I was like, oh my God, I want this. And then Cider has something that is somewhat like this feature, not exactly like it, but still very useful. So in this case, we are just can step through, and we get another data structure which is now more condensed, because it actually parsed the tokens from the language. And once we evaluate it, we get a result, a string which is which fits the string with the screen, and I don't need to expect it anymore. So if we try to run like a more complicated code, like creating a function and then calling it, so on for like x as a parameter, return x plus 1, and then we call it foo, say 5. Now, if we tokenize this, we get a huge data structure, and Cider actually keeps us sane and hides most of it. So it is represented with these 3 dots. But we can basically tell me, Cider, show me the data structure in all of its glory, and it will happily agree and show it. So in this case, if you're really interested into something, we can just, again, go into it and check it. So if it's a really huge data structure, that's the approach I'm usually using to inspect it. It may take time because you have to set up debugger and you have to actually pass some data to the function you want to inspect, but usually it pays off because you can fix bugs very, very fast because you can literally see when the bug is happening, when something doesn't align your expectations, basically.
And can you change code during debug session? So when you're inside debugger in the middle of the function, can you add a new expression and just evaluate?
Yes, you can, but I sincerely don't know how it works.
Okay.
I never do. It has this like eval in it, and you can say, okay, now let's say that we are evaluating expression of an empty vector, and the result of this form will be empty vector. So now we'll continue with like empty vector as its value of the result of tokenized function. In this case, I don't think I ever found this really useful. It's not like common Lisp debugger where you can like really go nuts and evaluate a lot of code, define new functions. You have like a new REPL completely off with prompt and stuff, and it's crazy. So I don't do it in Clojure because it's really rarely needed. It's easier to find a place where your expectations doesn't meet what actually happens in the code and just change it and reevaluate a function. So this is my workflow, at least.
So can we summarize the workflow? Let's say that you know that in function run there's some problem, yes?
Yes.
And it's not clear from the first glance what's going on. So you're starting debugging session and walking through this.
Yes. And
then
I analyze what's happening. I see that some function returns something, and then I look at what function expands to return. So, for instance, if the bug was that say the errors was never returned from the tokenize, and I always get nil here, even though I've manually made sure that my next expression has an error. I will see it basically because, okay, now I see errors is never there. And actually, I had a bug prior to this session. This function wasn't updating locals. So basically, instead of like setting this def one's volatile, it was just returning locals that we were using for the next execution. And well, I can show you. So let's say that we always are passing an empty map here. And if I evaluate this function and go to the REPL, because we already have it, I have defined this function foo. But now if I try to execute foo like 5, I will get an error because it doesn't know what X is like in this example, because locals were never stored for the next invocation, and now we can't find it. And again, once I am running this in a debug mode, and I can see that once I've evaluated the function definition, and now I've updated locals, I can see my local variable is here. It has its position, it has its like depths inside of local scopes. So, okay, it's here. Now we have evaluated it and we see the result as function. Now we evaluate the function call, and we go and like, okay, now our locals are empty, even though there should be locals because we already defined this function. And I was like, okay, so I'm missing something here in this particular place. So how do I fix it? And the result was to actually keep locals inside of a volatile. So yeah, so this particular way of thinking about your code may be not very fast, because you have to reiteratively like re-execute code until you got where the bug actually happens. But there are a lot of situations when the code is so convoluted that you can't do it otherwise, because otherwise you would have to study the code and it will take even more time than just stepping through it. So my workflow, as you asked, is I find a function that I think has bug, I step through it. I think if everything that I see is okay or not. If I think that everything is okay, I will go into the functions these functions using. So I will go into jump into the update locals function like here. And I will look into maybe I've made a mistake in here. So if I can see it and I still think it's here, I will step through this function, or I can go in from the debugger session that is already active. And once I fix the bug, I basically write a new test for it if it makes sense to test this particular situation, which mostly always is. So, and then I commit. And for committing, I'm using Magit. I think it's pronounced like this. And Magit is an amazing Git client for Emacs. So as you can see, we made only one change in this project, which is breaking our test, which is not good. So I will discard it. Yeah.
Cool. So, and you said that you are using a lot of Emacs stuff. So, for example, how do you use some Emacs tool like org mode for documenting code, or maybe tracking stuff like this? Yeah, can you share your experience?
Sure. Well, funnily enough, when I was starting with Emacs, you asked me what was my journey to Emacs. I went to Reddit and asked people, okay, make me use Emacs. Tell me stuff that you are think Emacs is good. And this is a super stupid and very, very popular question, because a lot of newbies come to Reddit and ask, like, why Emacs is awesome. And every single time there is comment which basically says org mode and nothing else. It's just org mode. And I was like, org mode, what is it? Well, it's something like Markdown, but when you can use it only from Emacs, what's the point? And then I actually used org mode, and I was like, oh, okay, I understand now. I'm totally converted, and I can't live without org mode. And speaking of org mode specifically, at work we have like sessions for basically presentations when you can. I am like the one who manages this community, and you can come to me at work and say, okay, well, I have this cool topic I want to talk about. Can you arrange a meeting? And we basically arrange a meeting with like video, and people share stuff they think interesting, and I do as well. And when I do it, I use org mode for presentation. So I think it's also a nice thing I can show.
Can you show how you do it?
Yeah, of course.
Quickly, let's create this simple presentation, or maybe you have one.
No, I don't have, but again, via project L, I can create a new file in the root of the project. So here, let's call it slides. And it's created. So when I'm presenting, I usually set up a title, like and my name and the date. And for date, there's kind of a cool thing about org mode. It has a built-in calendar. So as you can see at the bottom, the calendar appeared. So I can just take the date from the calendar. For this instant, it will be inserted like this. So this is basically cool. And then we can begin writing slides, like slide 1, which will have some bullets, I guess, like full bar, and the next bullet will be fuzz, for instance. And basically, when we are done with our list, we can go to the next slide. I'm sorry, like this, slide 2. And what's great about org mode, because it is actually not just a markup format like Markdown or like ASCII doc. I guess there are a lot of markup formats right now, but org mode is another application inside of Emacs. It is more like a word processing tool, like Microsoft Word. I should not compare org mode to Microsoft Word, but I think it's the closest one you can get, because you can use a lot of stuff for formatting text, but you can also write stuff like spreadsheets, for instance. If I have to present something like, I will not write meaningful text, but when I want, I can do stuff like actual tables, and by tables I mean are actually tables that can run functions. You can run calculations like in Excel, for instance. So it's really powerful. But in case of how I use it for presenting, I usually write code snippets like for Clojure, and you can do it like here. And what's cool about that is that you can actually run this code. So here it just print me result 6 because I've just evaluated this code from an org mode file. And when I'm doing my presentation, I usually enter like a present mode, which is org free slide mode package. So as you can see, it just removed everything else from the file, but the title and the slide title and the list that I've had at first slide. But when I go to the next slide, I forgot what is the shortcut for that.
I think arrows should work, huh?
Yeah, it's like angle brackets. So when I go to the next slide, you can see it updates the slide title and the contents. And as I talk about my topic on the presentation, I can actually evaluate the code, and it will basically blow everyone else's mind because they have never seen an interactive presentation before.
And what REPL would be used for evaluating this expression? Is it your running CIDR session, or?
Yeah, in this case, it's the REPL for the project we are currently in, and we are currently in the CLG logs project. So if I say in NS, say CLG logs runner, and now we are in that namespace, so we can say run 1+2, and it will even go to the debugger that we have previously set up. So you can demonstrate stuff from your actual project using your actual environment. It's pretty cool.
So usually, instead of readme.md, you're creating readme.org, yes, no?
No. Usually we still use readme.md because org mode is Emacs specific, and even though everyone is in our team using Emacs, except maybe one person which wants to use Emacs, so it's not a problem for us. It's still a problem for everyone else because not everyone else can view org mode.
I think GitHub knows how to parse
and present it supports it, yes. But first of all, the support for org mode is a bit clunky. At least GitLab is especially bad at it. It can't do syntax highlighting, for instance, but GitHub does, and it basically works. But still, I don't think it's really meaningful unless it's something directly tied to Emacs, because, well.
What other features of org ecosystem do you use? Do you use org agenda or time tracking? All this stuff?
I tried, but it didn't stick to me. I'm not really into planning ahead too much. Usually I just write on paper if I really need a plan. It's just easier because the less work you need to do to manage your work, the better. And in my case, if I need a plan, paper, pencil right away. So yeah.
And what is your position about documenting your code? So what's your approach? At least
yeah, good question. Can I actually move away from Clojure for this bit? So I have already mentioned Fennel, like participation project, which I work on a compiler for Fennel, but most of my time spent with Fennel, I do like writing libraries. And for instance, so we don't move away too much, CLGlib is a cool library for Fennel, which I wrote, which is a library that ports a lot of Clojure core functions to Fennel. So in this case, you can see it even has the same syntax for functions like Clojure, except this def and macro is something that I wrote for the language. It's a part of this library, and you can see it has documentation. So what I believe is that documentation of a function is everything you need to understand this function. So when I am working on libraries for basically for Fennel, I have these like huge documentation things. Like this one is somewhat big. At least it's bigger than Clojure one, and it has tests inside of it built in. So I made a project called Fennel doc. Here it is, and this project is basically a tool for converting doc strings from your code into documentation files. And I know that a lot of people are like opposed to the idea of generated documentation, but I don't. So why not use it? I don't know. And I think it all comes down to how well your documentation is written for a function. Because if you have great documentation written for a function and then you export it to a file via some kind of tool, like FennelDoc in this case, it's still a good documentation, especially if the tool makes sure that you have like cross links and stuff and this kind of other interesting things. So in this case, if I go to like my GitLab for a moment, and my PC is a bit lagging because of Zoom, but it should be okay. Let's go to GitHub, it will be better, faster. So if we go to GitHub and open, say, CLGlib here, the documentation for my code usually looks like a single or a pair of files in Markdown, which are properly formatted. It has a table of contents with all the functions. You can go to any function and there is its signature, its documentation. If it has like a cross reference, it will be automatically made jumpable from the docstring. So I made, and a key point here is that documentation should not lie, because comments like comments in the code are notorious to being deceivable, because if you wrote something in a comment and then you forgot to update that comment no longer represents the actual state of things. And it's also true for documentation, because we often update our code and then forget to update the documentation. So in this case, I'm writing documentation tests which are run as part of the test suite. And I use make in Fennel because Fennel doesn't have like tool project automation tool like Landingen or Debs Eden. So make test. In this case, we'll run all of the tests from this project. And if we make like an error here, like we change this to say vector, I'm sorry, like this. And you can see it has some warnings, but now we've basically broken our documentation because now it's not a map, and this should never return true. So if we are able to rerun our test, we should see an error with like a pinpoint of information where the error happened, what test caused it, what function, and you will see like right here. So it just states that for a function map ? in file init.fnl, this particular test has failed because the result was false. And I think I'd like to have something like this for Clojure, but because Clojure is not my language for hobby projects, I have never bothered to find if Clojure has something like this for documentation exporting. And at work, we usually don't export our documentation into like separate files. We usually ship it to other programmers which work as part of the code itself. So it's not like they can go to the universal place and read about what every function does. Usually it's part of the code itself, but it still has good doc strings with a lot of information, with examples and stuff. It's just like not put into a single file. So if I could, I would very much like some kind of tool that does what I showed you for Fennel, but for Clojure. But I have not spent time to either find it or write it myself yet.
Yeah, that sounds very interesting. And can you tell a little bit more about this Fennel language? What the motivation? And so it's your hobby project, yes? Why you believe in Fennel? So what the reason for this language to exist?
Well, it's funny because, well, Lua is just a really small language, which is usually used for embedded scripting. Like you can embed Lua into like Postgre or like into World of Warcraft. Or Roblox is using Lua.
I know a lot of high-load projects like Lua because it's quite easy to add for scripting.
Yeah. Even though I never used Lua in any of the project I've mentioned, it's still cool to see a language which is so tiny that you can embed it into anything. And I basically use Fennel just because it is fun. Like Lua runtime is so small and tiny, yet very, very flexible. Like you can do a lot of stuff with just Lua as it is. For instance, this library implements lazy sequences, and it does it in such a way that basically when you, by lazy sequences, I mean Clojure like lazy sequences, with all of the Clojure like semantics except for chunks. There is no chunks in here because I have yet to implement them. But basically when you are, let me find it. So for instance, this function lazy-seq, it accepts a function, basically it's the same function as in Clojure. It accepts a function that will return a sequence, and the result will be lazily appended to another sequence. And in this case, this function returns a table, and in Lua, everything is a table. There are no lists, there are no arrays, except, well, there are arrays, but they are part of the table. And this function returns a table with a bunch of meta methods which alter how table works.
But table essentially in Lua, it's like hash map, yes?
Yes, it's definitely just a hash map with a dedicated part for like sequential data. So it is a hash map, but it also has an array part built in. But like it's a bit complicated. But in this case, we are just returning an empty hash map, and this hash map has a call function. So you can call hash map as a function like we do in Clojure. And this call function basically calls realize, and realize is this Clojure which mutates the meta table of our table. So it basically says, okay, now since we have called this function once, we are replacing the meta method for call with a new meta method, which will return the data. So it's like caching built into this table. And that's what makes it possible for us to have lazy sequences that evaluate data only once. So in this case, I've just opened a REPL for Fennel, and in Fennel, I actually use REPL a lot heavier than in Clojure because I don't know why, I just do it. So in this case, we can like require lazy. So we just required the library, and if I, by the way, the Emacs mode for Fennel is one I'm also one of the maintainers for, and I've made these like pop-ups for completion and documentation, which you can see now. So it's also can show you that documentation is important, because now you can actually see the documentation for map function here with examples and stuff. So it's also, so if we try to lazy map, for instance, over a vector with a function which, let's say, just multiplies one by itself, we get a sequence back. And this sequence is actually of a table type. So if we evaluate type, we get a table because it's a table. But it acts as a sequence, and if we try to call lazy first on this, it will return 1. And if we call lazy last, last rest, it will also return a sequence. So it basically implements all of the features you might expect from a lazy sequence. But as I said, if we like put an say a nil in quotation marks, which basically is string, and we'll try to multiply string by itself, it will obviously break. But if we take only the first element, it will not blow up because it's lazy. So basically, it's a lazy sequence.
Yeah, that's interesting. So let me just understand. So the Fennel, it's a Lisp on top of Lua.
No, Fennel is Lua, basically.
Fennel is just Lua, yes?
Yes, it just has a Lisp-like syntax. So it has a syntax, which
yes.
So here,
can you maybe open the landing page for Fennel?
Oh, okay, yes, of
because
course.
it's very it's still not very known technology. So okay, so there's a language with a Lisp syntax, yes?
Yes. Basically, it compiles to Lua, and it has no extra semantics on top of it. Okay. So it's just a surface like language for Lua, basically just as expressions for Lua.
So it's just a Lisp syntax to write Lua.
Yes. But it has macro.
Yeah, and you, what are you doing? So you are kind of porting some functions from Clojure as a library for the Fennel, yeah?
Yes. So if we open the project Fennel doc, which I've already talked about, and we find a file like, say, let's look at Markdown. So you can see here that I have an ns macro which has syntax a lot like Clojure. It is a macro which is a part of the CLG lib library which I showed before, and you can see it has defn with private. So this code basically looks like it's Clojure, but it's not Clojure, it's Fennel. And you can see that we have like some bits like with a dot as a separator. It's a lookup table. In Clojure, this actually would be a slash, but in Fennel, it's a dot because Lua uses a dot here. So basically, what I personally do with Fennel is making it look like Clojure, feel like Clojure, have the same semantics as Clojure because I like Clojure, and the Lua lacks in some semantics, like it doesn't have immutability, which Clojure is basically known of.
So you plan just introduce as many Clojure-like features as you can, yes? So and you have these persistent data structures on your roadmap, or you already implemented?
They are already implemented, except they are not really implemented like in Clojure. It's not hash array map tries. It's implemented via immutability by copying. But it's just the first step. Maybe in the future I will implement it in a more performant way. But I have transients, I have lazy sequences, I have like transducers, I have like loop recur macro, which is not a part of Fennel, but now it kind of is. So I think it is exciting stuff to have in another language.
That's amazing. Yeah, and is there any chance that you will eventually just implement the closure on top of Lua? So what's the missed part, or there's some blockers on this way? So can we see like closure script like Lua closure Lua or something like this? So
it's possible. Yes, it's possible, but well, there are some problems. Well, first of all, Fennel is not a closure port. It's
yeah, I understand. So it's just another language, but potentially you may implement like a full closure spec, like closure C or closure script.
Well, it will require me to re-implement the reader from closure, basically, because Fennel's reader is not
so it's not completely
it's not compatible. For example, it doesn't support tag literals. Like it's a major block for porting closure, so it doesn't have like tag conditions for like when you switch between closure and closure script in the same GC file. So there are some like problems, but if we ever go to like this goal, it will require a lot of work, and as a result, there may be another problem that Lua is just really slow language. It's not slow, like super slow. It's generally faster than Python, but still, if you are generating a lot of garbage, which Clojure does, it can be really painful for Lua runtime because it has a garbage collector, which is basically sweep, and it can't handle a lot of short-living objects. But recently they've added generational garbage collector, which should help with that. I'm not sure how efficient it is just yet, but in my use cases, it was fine. And also there is like a JIT implementation for Lua, which is super fast. It constantly like winning the fastest scripting language awards every year because no one can approach the speed of Logit, because Logit generates so efficient like native code that basically it is in its own league right now. But it has super stupid problem because Lua-JIT implemented Lua 5.1 version of Lua, and we already have Lua 5.4, and they are like have incompatible features in sense that Lua 5.4 removed some meta methods. Lua 5.1 even doesn't have these meta methods yet. So there are a lot of stuff that basically makes it hard to make an efficient Lua based scripting language, but it's possible. It's possible.
But as I know, so the Lua is designed as an embeddable language, and it's very easy to kind of breach with this native code, like written in C, yes, or in Rust. So potentially you may implement all the critical closure stuff in C, and then we will get very fast closure. Yes.
Yeah, it's possible.
Embeddable.
Yeah, but actually about embedding, Fennel is also great if you want to write games in Lisp, but you don't want to learn like common Lisp, or you don't know how to do it with Clojure script, for instance, but you happen to know Lua and you want a Lisp. So for instance, here is a game that I'm working on. It's in very, very early stage. It's nothing like playable yet, but if I execute this function, it basically creates a window with which I can move and jump. So it is written in Fennel. You can see the code is right here. And it is efficiently compiled on machine code by the game engine. So it's possible to create fast stuff. It just, you need to be aware of some quirks of Lua runtime that are presented, which, to be honest, there are a lot of quirks in Lua, which not everyone will be happy about.
Yeah, I've seen some projects when the engines was extended with Lua. Yes, like So you will be able to be inside engines and write some stuff like connecting to database, writing REST services.
Yeah, this is an image generated with Fennel. It has basic like ray marching algorithm implementation. It took me about 7 minutes to render on the CPU, so it can be slow, but the algorithm itself is like 330 lines. So Fennel can be really compact as Clojure, because everyone is talking about how Clojure makes your projects smaller because you have less code that you would have in Java. Well, Fennel is the same thing, but for Lua. So it's another point of liking it.
Okay, and
yeah,
thank you so much. I think that's enough for today. Yes, probably we'll do the next time when you progress with the Fennel and other stuff. Thank you so much
thank
for
you so much
visiting
for having
us
me
and sharing your experience and your hobby projects. Everything looks amazing. Have a good day. Bye-bye.
Yeah, thank you. It was a pleasure. Bye.